In this lesson, we're going to look at finding equations of circles, and we're going to write these equations in standard form. Now remember, standard form is this. So the standard form of equation of a circle is this: x minus h squared plus y minus k squared equals r squared. So that's the standard form that we're referring to. And remember, the standard form, if an equation of a circle is written in standard form, you can easily determine the center. The center of that circle is HK. Just keep in mind, though, that when you determine HK, in your mind you're saying x minus h and then y minus k. All right, so don't say negative h, negative k. It's x minus h, y minus k. Okay, and then the radius, the length of the radius is r. All right, now in these set of problems we're going to look at, you're going to be given, for the most part, you're going to be given, for example, number one, it says this: find the equation of a circle with the given information. So you're told that the endpoints of a diameter of the circle has these points, 3, 6, and 7, negative 2. Okay, now let's kind of look at what you're seeing in terms of this. So if you were to draw the diameter, you would probably get more information as to, hey, I now know what I need to do. So if you have 3, 6, so if you look at the point 3, 6 right here, okay, that's the point 3, 6. And then the other point is 7, negative 2. So that is here. Okay, and so if I look at that diameter, if I look at that diameter, I get this. Now remember, this is the diameter of a circle, right? So if I were to kind of draw that circle, and I'm going to do a very bad job at it, I'm going to get something that looks like this, let's say. Okay? All right, so I did a very bad job at this circle. But the point being this. So if I'm going to use the equation of a circle in standard form, and I want to write this equation of the circle in standard form, then I need to know the center and the length of the radius, correct? Okay, so how do you think you can determine the center? So here's the center of a circle, of this circle right here. All right, so what do you think you can do to determine the center of the circle? Okay, so you remember you had some information on midpoint. So I can find the midpoint of this diameter. So remember, a circle has an infinite number of diameters. So the diameter of a circle always goes through the center. That's one of the things you learned in either high school geometry or geometry from middle school. But that is the center of the circle. So the center of the circle is the midpoint of one of the diameters, and there are an infinite number of diameters. You were just given these two. I'm sorry, this one that has these two endpoints. Okay, so what you want to do, number one, is this. Okay, so number one, first thing you have to do is determine the midpoint of the diameter. Determine the midpoint of the diameter, because the midpoint is going to be the center of the circle, and that will be your HK. So determine the midpoint of the diameter. Okay, so the midpoint formula is this. So remember, the midpoint, I've given 2 points, and I'm going to go ahead and label this. So this was 3, 6, and this is 7, negative 2, right? Okay, so let me go ahead and label and write the points here: 3, 6, and 7, negative 2. So remember, the midpoint says if you're given 2 points, of a line segment, and I'm going to call this x1, y1, x2, y2, and so basically the midpoint, remember the midpoint's a point, okay, and so you're going to take the average of the x-coordinates, the sum of the x-coordinates, and you take the average of the y-coordinates. So basically you're saying x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. So that's your midpoint formula. So you take the average of the x-coordinates and take the average of the y-coordinates. And so notice I labeled these, so we're just going to plug those values into this formula. So the midpoint in this case will be the center of the circle then. The center of the circle will equal, all right, so 3 plus 7 divided by 2, right? So you add your x's together and divide by 2, and then you add your y's together. So 6 plus a negative 2 divided by 2. And so I get 10 halves, comma, and then 6 plus negative 2 is 4, 4 halves, which you need to reduce. You need to simplify. So that's going to be 5, comma, 2. So what I found here, and is that this point right here represents, and it kind of looks like it is, it's a little off, but 5, comma, 2, right? So that's your center. So I found the center. So the center is 5, 2. So there's my H, there's my K. All right, now, all I need to do now is find the radius. Find the length of the radius. Okay, so remember, if this is a diameter of the circle, then remember that the radius is this part here, right? So from the center to a point on the circle. So if I want to find the radius, we just need to remember that, all right, so to find the radius, you just have to remember that the radius is half the diameter. Half the diameter. So you can do one of two things, and it's up to you. You can find the length of the diameter and then divide by 2. Or, since you now know the center, then you can just find the length from the center to this point here. But here's the problem. I wouldn't do that because you could have messed up with the center. So you could have gotten these points here, these coordinates here to be incorrect. So I would just go ahead and use the given information. That's what I would do. I would always use the given information, find that length, and divide by 2. I would not use this because I could have made a mistake in this process. Okay? All right, so to find the radius, we're going to first of all find the length of the diameter. Length of the diameter. And then divide by 2. Okay? So remember the radius is 1/2 the length of the diameter. Okay, so the radius is 1/2 the diameter. Okay, so we have to use the distance formula. Okay, so no big deal. I know the distance formula. We know the distance formula. So distance is the square root of, remember you subtract your x coordinates and then square. And the order in which you subtract does not matter because you're squaring it. So in one order, some of you are probably going to get a negative number, and some you're going to get a positive number. But it doesn't matter, does not matter, because you're squaring it, and it's always going to be positive. So this value should be positive or 0. It should never be negative. Okay. And then you do the same thing with the y coordinates. y2 minus y1, that should be y1 squared. Okay, so we know our points here of the diameter, the endpoints of the diameter. So let's find the distance of the diameter. Now remember, this is going to be the distance of the diameter. Okay, so that's going to be the square root of, and then I subtract the x coordinate. So 7 subtract 3, whatever that is, I'm going to square, plus, and then negative 2 subtract 6. 6, and then square. All right. Now we're going to simplify the radicand, so that becomes the square root of 7 subtract 3 is 4 squared, plus a negative 2 and a negative 6 is a negative 8 squared. So I get 4 squared, so maybe work within the radicand. So 4 squared, 16, plus, and then negative 8 squared, negative 8 times negative 8 is a positive 64. And then using your calculator, 16 and 64, that should give you, what's that, 80? The square root of 80? Okay? So the length of the diameter is the square root of 80. Now I would just go ahead and leave it like this, and you're going to see why in a little while. Don't simplify this. Remember how we simplified the radicals earlier? Don't do that, and you're going to see why. Just leave it at square root of 80. All right, now keep in mind that that's the length of the diameter, right? The length of the diameter. Square root of 80. Okay, but I want to find the length of the radius. That's what I want to do, because I want to find the length of the radius so I can put that value here. Okay, so the radius, the length of the radius, remember, is half the length of the diameter. So the radius then would be 1/2 the square root of 80, which is, I'm going to rewrite this as square root of 80 divided by 2. Now don't make the mistake and say 2 goes in 80, because that's not 80, that's the square root of 80. All right, so that's not 80. So don't say that's going to be 2 into 2 is 1, 2 and 80 is 40. Okay, you know that's not possible. That's not a true statement. All right, so that's the length of the radius. So now we're going to take this information, this, and we're going to substitute it into our formula. Okay, so here's what we get. So substitute the center and radius into the formula, into standard form. All right, so here we go. X minus h, remember h is 5 squared, plus y minus k, k is 2 squared, equals the radius, which is this, squared. Okay? Now, don't leave it as this. We expect you to simplify this. So if you leave it like this, you're not going to get full credit, because we do expect you to go a little bit further with this little part here, because you have the prerequisite skills to determine this. So my answer will be x minus 5 squared plus y minus 2 squared equal, okay, now let's talk about this right here. Y'all agreed that the square root of 80 divided by 2 squared means the square root of 80 divided by 2 times the square root of 80 divided by 2, right? Now we all know that the square root of 80 times the square root of 80 is 80. And then 2 times 2 is 4. Now, if you didn't know that the square root of 80 is 80, then do this. Do 80 times 80, okay? You get this, you get 6,400, right? And then the square root of that is 80. Okay, so remember, the square root of a number times the square root of that same number is just that number. And then 80 divided by 4, we get 20. So that's 20. So that goes here. All right, so that's the answer to number 1. Okay, so it's a long process, but that's what you do when you're given the endpoints of the diameter. Okay, so you have to first of all find the midpoint of the diameter, which is going to be the center. Once you find that, then you got to find the length of the radius, which is half the length of the diameter. So you have to use the midpoint formula, and you have to use the distance formula to do that. Okay? All right, so that was number 1. Let's look at number 2. So in number 2, it's going to be the same idea. So this time the endpoints are -5, -2, and -2, 10. Okay? So remember, just like we did this, I'm not going to draw the picture, but just like we did this, the first thing you got to remember is this. All right, so here's the endpoints of my diameter. The center of the circle is the midpoint of that diameter. So we got to find the midpoint. So let's find the midpoint of the diameter first. All right, so this is number 2. So number 2, we have this. So remember, we have the points being the endpoints of the diameter being -5, -2, and -2, 10. Okay. So in order to write the equation of a circle in standard form, we need to know the center and the radius. That's what we have to find, the center and the radius. All right, so the center is the midpoint of the diameter. Okay, so the center is the midpoint of the diameter. And so if these are the endpoints of the diameter, then the midpoint of this is just the average of the x-coordinates and the average of the y-coordinates. So the center then is, okay, so we're going to, remember, if you need to, just go ahead and label these x1, y1, x2, y2. And remember, the formula for midpoint is x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. So that's your midpoint formula. So you take the average of the x coordinates, take the average of the y coordinates. All right, so I get -5 plus a -2 divided by 2, comma, and then -2 plus 10 divided by 2. So the average of the y coordinates. So if I simplify this a little bit further, I get -7 halves, comma, and then this is 8 halves, right? Now go ahead and rewrite this, reduce if you can. So that's going to be -7 halves, comma, 4. So there's your h, there's your k. All right, now the next thing we have to do is find the length of the radius. So remember that what we're going to do is find the length of the diameter, and the radius will be half of that. Okay, so now we need to find the length of the diameter. All right, so that's where we're going to use the distance formula. So remember, the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, and so the so I'm just going to take these values, plug into the formula. So the length of the diameter, remember we're finding the length of the diameter, so the distance will be the square root of, all right, so you subtract the x coordinates. Doesn't matter where you start, I'm just going to start with -2. So -2 subtract a -5. See, that's how it looks. So you got to remember you're subtracting, so you're subtracting the x coordinates. See how it looks? Subtracting the x coordinates, and you're squaring. Plus, and you're going to do the same thing with the y coordinates. You're going to subtract the y coordinates. My y coordinates are 10 and -2. So you can say 10 subtract the other y coordinate, which is -2. Whatever that is, we're going to square it. Okay. Now, go ahead and deal with the radicand. So that's going to be the square root of. Okay, so remember, in a previous course, you learned that you can always change subtraction to an addition. So by adding the opposite. Okay, so you need to remember that -2 subtract a -5 means -2 plus the opposite of -5, which is 5. So in other words, this becomes -2 plus 5 squared. Plus, and then this becomes 10. Subtract a -2 means 10 plus the opposite of -2, which is +2. So this becomes 10 plus 2 squared, which equals the square root of, okay, -2 plus 5 is 3, so it becomes 3 squared, plus 10 plus 2 is 12, so it becomes 12 squared. All right, now going a little bit further, 3 squared is 9, 12 squared is 144, and so then I get the square root of 153, okay, and then leave it like that. Don't try to simplify this, because now we got what we're going to do is this. Now we know the length of the diameter, which is this. So the length of the radius then will be half of that. So the square root of 153 divided by 2. Square root of 153 divided by 2. All right. So now we're going to take this information, that and the center, and substitute into our formula. So now substitute into standard form. All right, so we get x minus h. Remember, h is this. Now go ahead right now and just leave it like this for right now. You're going to rewrite this because you don't want to leave it like this, but for right now, write it like this because that's what the formula says. X subtract h squared plus y subtract the y coordinate of your center squared equals, and in parentheses you put the length of the radius, which is this, the square root of 153 divided by 2 squared. Okay, now don't write your answer like this though, because we do expect you to go further with some of this. So you need to remember that x subtract -2, just like we did this subtraction, means x plus 7 halves. So x subtract -7 halves means x plus 7 halves. So you got to rewrite it like this. That's how we expect you to rewrite it. Plus, and then that's going to be y minus 4 squared equal, now let's go ahead and deal with this. So remember, the square root of 153 halves means the square root of 153 divided by 2 times itself. All right, and then the square root of 153 times the square root of 153 is 153, and then 2 times 2 is 4. And so that is what goes here. So this goes here. So 153 divided by 4. All right, so there's your answer. All right, so that's standard form. Okay, so that's number 2. All right, number 3, we have this. And number 3, we have, okay, so the center is at 3, -3, and it passes through this point, 6, 4. So let's look at a picture of this, just to give us an idea of what's going on there. Because in the previous 2, you were given the endpoints of the diameter, right? You're given the endpoints of the diameter. And so we talked about, we discussed, all right, given the endpoints of the diameter, how can I find the equation of the circle? All right. Now, what's happening is that you're not given the endpoints of the diameter. What you're given is this. So let's look at a picture of this. It helps sometimes to visualize what you're dealing with. So it does help. So you're told that the center is 3, -3. 3, -3, right? All right, so right away, don't I know HK? I know HK, right? Okay, well, that's a good thing. In the previous 2, I had to find it. And it's passing through the point 6, 4. So here's 6, 4. 1, 2, 3, 4, right here. Okay? So here's the center. It passed this point. So I'm going to ask you, what is this distance right here? What is that right here? So this is the center, and the segment that goes from the center to a point in the circle, because you know you're told it passes through that. What is that? That's the radius. Now I'm doing a very bad job with graphing this. I'm doing a very bad job with graphing this circle. All right, so that's the radius. So here's your center. So you're told the center is 3, -3, right? You're told this point right here is 6, 4. And so all you have to do is find the length of this radius. All right, so here's number 3. Okay, so given this information, so it helps sometimes to draw a picture of what you have. Okay, so in number 3, we already know the center, right? The center is 3, -3. So there's your H, there's your K. All we have to do now is find the length of the radius. That's what we have to do, find the length of the radius. All right, well, the radius is from the center to that point that the circle passes through. So the circle contains an infinite number of points, correct? But that's the only one you're told about. So we're going to use this. So to find the length of the radius, I'm going to find the distance between these 2 points. This point, the center, and the point on the circle. So to find the length of the radius, you find the distance between the center, 3, -3, and 6, 4. Okay? So let's go ahead and do that. So I'm going to call this x1, y1, and x2, y2. So hopefully you'll understand that I don't have that finding the using the midpoint form is not used here. You understand that, right? Because you're told the center. All right, so all you have to do now is just use the distance formula. Okay, so distance equals the square root of, remember you subtract your x coordinates. So I'm going to start with 6. So 6 subtract 3 squared, plus then you subtract the y coordinates. 4 subtract -3 squared. Okay, so remember you subtract your x coordinates. Always think like this. Subtract, you see the subtraction symbol? These were my x coordinates. Subtract, these were my y coordinates. Okay, equal. Now let's simplify this parenthesis. 6 subtract 3 is 3, and I'm going to square that. Plus 4 subtract -3 means 4 plus 3, which is 7. I'm going to square that. So I get the square root of 3 squared is 9, plus 7 squared is 49. And so I get the square root of 58. Now don't simplify this. Leave that alone. Okay, leave that alone because at the end, remember you're going to be squaring it. So leave it alone. Don't simplify that. Don't make things difficult on yourself. So that's the length. This right here is the length of the radius. Now don't confuse that with the previous one, because remember the previous one, that was the diameter we were finding. Okay, so then the length of the radius will be half of that diameter. Here though, this is not the diameter. This segment is not a diameter. This segment is the radius, is one of the radii. Remember, there are an infinite number of radii here. Okay? All right, so then we substitute into our formula. Substitute into standard form. So we get this. We get x minus h, which is 3 squared, plus y minus k, which is negative 3 squared, equals, in parentheses, I'm going to put the radius, which is square root of 58, and I got to square that. And remember, don't leave it like this. Do not leave it like this. I keep telling y'all that. Do not leave it like this. We expect you to go a little bit further with some of this information. For example, this part here, y subtract negative 3, we expect you to know that that means y plus 3. So you got to rewrite it like that. And we expect you to simplify this part here because we all know that the square root of 58 times the square root of 58 is just 58. And so there's your answer. Okay? All right, now before we go on, I just want to kind of remind you about a couple of things. Some students get confused. They can easily find the center. So the center here would be 3, negative 3. But for some reason, they seem to think that that's the radius. It's not the radius, right? The radius is, remember, this right here represents r squared. So the radius will be the square root of that. So always be careful. All right, that's not the radius. That number, 58, represents the radius squared because that's part of the formula, right? So this number here, that's r squared, not r squared. All right, so always make sure you understand the different parts of what you're dealing with. All right, so that was number 3. Okay, let's look at number 4. Okay, number 4, we have this. So number 4, this time you're told the center is negative 4, 6, and it passes through point 3, negative 1. All right, so in your mind, and sometimes it helps to think about what you're dealing with in your mind. Okay, so for example, you're dealing with this. So you're told that the center is negative 4, 6. So right away, I know HK. All I have to do is somehow find R. I got to find R. I got to find the radius. All right. So in your mind, you know this. You know that the center is negative 4, 6, which is here, right? And you're told that it passes through the point 3, negative 1, right here. Okay. So there's the center. And so let me go ahead and write the center. Negative 4, 6. And so it passes this point, 3, negative 1. So that's the point on the circle. That's what that means. So that means, remember your definition of the circle, that means that this length from here to here, that's the radius. All right, so if you were to kind of draw this circle, and I'm doing a very bad job with it, but you kind of understand that this right here would be the radius. Okay? All right, so to find the length of the radius, we just use the distance formula on these endpoints. So these are the endpoints of the radius. Now remember, there are an infinite number of radii, but that's the only point you know of. That's the only point that you're given that's on the circle. There are an infinite number, but that's the only one you know. So you got to use it. That's the only one you can use. Okay, so now to find the radius, we're going to find the distance between the center and the point on the circle. So this is going to be x1, y1, x2, y2. And so I'm going to use the distance formula. So I get distance equals the square root of, remember you subtract your x coordinates, so you subtract, see how I'm writing this, subtract the x coordinates. So 3 and negative 4 squared plus, and then you do the same thing with the y coordinates. Negative 1, subtract the other y coordinate, right? Okay, don't forget you're squaring each one of those. So then I get the square root of negative 3 subtract negative 4 means 3 plus 4, which is 7, and I'm squaring that, plus a negative 4 and a negative 6 is a negative 7, and I'm squaring that, right? So I get the square root of 49 plus negative 7 times itself is also 49. So I get the square root of 98. Now don't simplify that. Leave that alone, because at the end you know what's happening at the end. You'll be squaring this in the end, right? Which is just going to be 98. So now we can substitute all this information into our formula for standard form. So we get, so substituting, we get this. So we get x minus h, remember h is negative 4 squared, plus y minus k, k is 6 squared, equal, in parentheses, the radius, which is square root of 98, but I got to square that. Now remember, just as before, you got to rewrite this in a better way. So x subtract negative 4 means x plus 4 squared, plus this stays y minus 6 squared. This we know, the square root of 98 times the square root of 98 is 98. And there's your answer for our problem. Okay, so that's number 4. All right, number 5. So number 5, we have this. We have the centers at the origin and pass through the point. Okay, same thing, right? So your center is the origin. Now you just have to remember, though, that the origin is 0, 0. Okay? And so there's your h, there's your k. All right. And you're told that it passes through the point 8, 2. So if you want to look at a picture of this, in your mind, you kind of have an idea, I think, what this would look like. But if you want to look at a picture of this, here's the center right here. There's the center of the origin, right? And it passes through the point 8, 2, which is here. All right. So that means that the distance from the center to that point on the circle, so that's a point on the circle, so that's your radius right here. So the point here was 8, 2. So if you draw it, and again, I'm just doing a bad job with these, drawing these circles, but it looks something like this. Okay, and so that will be the length of the radius here. All right, so to find the length of the radius, because remember we have to find r now. So to find the length of the radius, we're going to use the distance formula from this point to that point. Okay, so find the distance between the origin, okay, and the point of the circle, which is 8, 2. So this is x1, y1, this is x2, y2. All right, so we get distance equals the square root of, again, you subtract your x coordinates, so 8 subtract 0 squared, plus, and then what? You subtract your y coordinates, so 2 subtract 0 squared. And so I get the square root of 8 subtract 0 is 8 squared, plus 2 subtract 0 is 2 squared. So I get the square root of 8 squared means 8 times 8, which is 64, plus 2 times 2, which is 4. So I get the square root of 68. Okay, don't attempt to simplify this, because you'll be squaring it in the end anyway, so leave it alone. So keep in mind, though, that that's the length of the radius, right? Okay, And so now we're going to substitute all this information into the formula. So substitute into x minus 8 squared plus y minus k squared equals r squared. Okay, so I know hk, so we're going to say x minus 0 squared plus y minus k, which is 0 squared, equals this squared. All right. Now again, you gotta remember things from the past, and also what we're talking about in this lesson. You have to rewrite this. You need to know that x minus 0 is x, so this just becomes x squared, plus y minus 0 is y, so that becomes y squared, equal, and then this, the square root of 68 times the square root of 68 is 68. And so there's the equation of the circle. Okay, so remember when you started talking about equations of circles, whenever you saw just x squared and there was no number in here, then that would mean that the x coordinate of your center is 0, and then same thing here, the y coordinate of your center is 0. All right, so that's the answer to this one. All right, and then finally, let's look at number 6. Number 6. So number 6, you're told that the center is at 6, negative 3, and it contains the origin. So this time what that means, if you want to look at the picture of this, what that means is this. Your center is at 6, negative 3, right here, all right, and it contains the origin. All right, so just like we did in the previous problem where you're told that the center is the origin, and it contains this point. It's just the other way around now. So it contains it. The center is here, and it contains this point. So it looks something like this. All right. And again, this is horrible, but anyway, you have the idea though, right? So that's the length of the radius right here. So that's your radius. So see here, that was your center. Here, this is the center. Okay? All right, so in this one, I know the center. So this is number 5. I'm sorry, number 6. So the center is 6, negative 3. So I know HK. So all I've got to do is find the length of the radius. So find R. That's what I have to do. So to find R, though, remember you're going to find the distance between these 2 points right here. So that is 6, negative 3. Okay? We're going to find the distance between this point and the origin. All right, so we're going to find the distance between 0, 0 and 6, negative 3. All right, so let's call this x1, y1, x2, y2. Does not matter which one's x1, y1, which one's x2, y2, does not matter. Okay, so the length of the radius then, the length of the radius will equal, so using the distance formula, the square root of, you're going to subtract the x coordinate, so 6 subtract 0 squared, plus negative 3 subtract 0 squared. Okay, so it becomes the square root of 6 subtract 0 is 6. You're going to square that. Negative 3 subtract 0 is negative 3. You're going to square that. So notice parentheses, those are important. So I get the square root of 6 squared is 36. And the reason why the parentheses were important is you can see that negative 3, if you didn't put parentheses and you use your calculator would give you negative 9. But remember, in our discussions, whenever you square that number, that better be positive. All right, so negative 3 squared is 9. And so the 36 plus 9, that's going to give me a square root of, and that's going to be what, 45? All right, square root of 45. All right, don't simplify this, so don't say that's going to be the square root of 9 times 5. That's not what we want you to do. Leave it like this because at the end you're squaring it. All right? So that's the length of the radius right here. Length of the radius. All right. Now, let's substitute all this information into the formula. Substitute into standard form. Okay, so here we go. X minus h, which is 6, squared, plus y minus k, which is negative 3, squared, equals the length of the radius squared. All right, now rewriting this, we get x minus 6 squared plus, and then again, y subtract a negative 3 means y plus 3 squared equal, and then the square root of 45 times itself is 45. And so that's the answer to that one. Okay, so that's going to take care of our lesson on writing equations of a circle given diameters and given the length of the radius. So this part right here dealt with the length of radius, and this part here was where the diameters were given, the endpoints of the diameters were given. Okay, so that's going to take care of this lesson.